So here's our question 5. I've labelled this as parameters and formatting because it deals with those two aspects as much as anything else. It could also have dealt with things like lists or files, even turtle graphics. There could be anything in here. Again, they're going to give you a specification, but notice it's not so step by step. It doesn't say this is what it needs to do and this is how you've got to go about and do it. It does actually give you some clues in the program itself, so as we go along I'll point those out. So what they're doing is they want to create a program that basically calculates the volume of a cone. So people are collecting data about the amount of water needed to fill different size paper cones. They're going to compare those measurements to a calculated volume, gives you the calculation. So what they're asking you to do is to complete a program and a subprogram to work out that calculation. Now, one thing about this one is that it has these arrows to help you. So if you remember that from earlier on in our questions, so questions 1, 2 and 3 maybe, it says import a library to use Pi. Well, if you're not sure, have a look in your PLS, but I happen to know that the library that contains Pi is the math library. I'm then going to read my code through, and it says hard coded for testing. So what that means is you're not going to change them. These are global variables. Now, a global variable is one that is in memory for the whole program, but we can only use it in the main program. So we can only actually use them directly here. We can't use those variables directly in here. And the reason for that is because if I was to start using them in here, it would treat them as a local variable and only use the values that it creates inside here rather than the original values from outside. So that's confusing, but the main thing to get your head around is that these variables are globals. Global variables only can be used in the main program. We can do something to send them to a subprogram, but we can't use them directly. The next instruction it gives us is add parameters inside the brackets. And we've got a def, so we've got a start of a subprogram. We've got calc volume, which is the name of the program. And then it wants us to put some brackets, some parameters inside these brackets. Let's read the rest of the code just to give ourselves a clue. So the radius prints the radius, p radius, prints the height, p height. Complete the calculations, so it looks like it's printing out the volume, which it seems to have got from somewhere. It's then returning the volume back to something. Can we figure out what the parameters are? Well, in order to create or calculate the volume of a cone, we need 1/3 pi radius squared height. Well, the pi we're going to get from the maths library. The 1/3 we can put in directly. But if you look at it, where are we going to get the height and the radius from? It looks like we've got two variables here, which they very helpfully labelled as p height and p radius. They don't have to do that, but those are our parameters. Those are the values that are going to help us calculate the volume of the cone. And they're called parameters, and parameters are passed from the main program. So the main program is going to send them these values. So the height and the radius is actually going to be sent from here to here in some way. We'll worry about that when we get there. Next thing, complete the calculation for the volume. So I need to think about this for a moment. Do I have a variable to store the volume in? It hasn't told me anything about that. Oh, there it is. So I've got the volume. I'm going to copy and paste that just in case I make any errors with my typing. I can now use my volume formula, and I'm going to space things out as much as possible, so just in case I've got some marks to go with that. 1/3. I'm going to multiply that by math.pi. That gives me my pi. I need to multiply that by radius to the power of 2. There's lots of different ways of doing this. So I'm going to use the exponent exponent way, so radius to the power of 2, and I also want to multiply it by the height. There we go. Just going to give myself a little bit of white space so it's nice and clear. Just check my formula, 1/3 times pi times p radius to the power of 2 times the height. That looks right. It now asks me return the volume to the caller. Well, the moment I see that and the moment I start to type in the word return, what we know is that this becomes a function. It becomes a subprogram that returns a value to you. And what we've got to return is the volume, which I know is that variable there. Okay, so that's the subprogram done. It now says call the subprogram, passing parameters, and catch the returned value in the correct variable. So it wants to catch the returned value in the correct variable, calling the subprogram, passing parameters. So I need to store it somewhere, and because it's a function, I need to store it in a variable. Well, is there a variable that I can use? Well, what's it doing? It's calculating the volume. Well, I've got a variable up here which looks like it's been initialized to 0.0 that stores the volume. So that, I think, is the one I'm going to use. And I want to call the subprogram. Well, the subprogram is called calc volume, passing parameters. Now, what do I want to send it? Well, I need to send it the radius and I need to send it the height. So what I know is that the radius is base radius, and the way that they've hard-coded the height is they've called it cone height. And one thing to notice is that these things line up. So base radius gets passed to that subprogram, that function, as p radius. Cone height gets passed to p height and allows you to use it in there. So that's effectively what they're asking me to do, just pass those values around. Because I can't use these directly in here, I have to pass them as a parameter in order for them to be used properly. Okay, the last thing it says is print the total volume to 3 decimal places using the string dot format by completing the pattern inside the 2 squiggly brackets. Now, a little bit of a warning. They've given us loads of space here. I'm actually going to remove that space because one thing that does happen with Python is if you have spaces inside this bit, it won't necessarily know exactly what you want. So it's one of those few cases where you have to really tighten up the code and remove any spaces. So if you're not sure about this bit, look for formatting inside the PLS. But I know with these, they always start with a colon. I could, if I wanted to, put it in so many spaces. So you could put a 5 or a 10 or whatever it was you wanted to. It's not asking me to do that, so one little trick I can do is just ignore that bit and just put a dot in there. I'm going to set it to 3, and because it's floating point, I need to put an F there. And there you are, completed run, and it's successful.